Welcome to Walkabout the Galaxy, the childish astronomy podcast, where the science is universal, the opinions are personal, and the trivia is astrohistorical.
Oh,
We are Strange, Charm, and Top the Astroquarks, also known as Josh Caldwell,
Addie Dove.
And Jim Cooney.
coming to you from the Walkabout studio and other locations near the University of Central Florida, thanks to the magic of the internet. Upquark, Hannah Sargent, is on international assignment and will be back with us on our next episode. The Astroquarks are recording an upcoming episode of Walkabout the Galaxy in front of a live audience at MegaCon 2022 at the Orange County Convention Center in Orlando, Florida, Saturday, May 21st at 11 a.m. We'd love to meet you there. Remember to subscribe to us on all platforms, including Facebook, YouTube, Twitter, and Instagram. Check out our website at walkaboutthegalaxy.com, where you can see how to order a Walkabout shirt. We're putting old sponsors and trivia on the website as well. You can contact us anytime at wtg@ucf.edu. Do contact us that way if you order a shirt so we can get it to you as soon as possible. Our Stumper today is inspired by a genre show, and we define genre in the broadest possible terms to include anything fantastical, science fictional. This one has a sort of cool time travel body snatching gimmick. It's a show on Netflix called Les 7 Vies de Leia. It's a French production, so it's the 7 Lives of Leia. And Leia,
Like Princess Leia?
it is French spelling of Leia, if you want. Leia discovers a dead body in the first episode, and then on each of the next 7 days from 30 years ago, and then on each of the next 7 days, she wakes up with her mind magically transported back in time exactly 30 years into the body of one of the people in the life of this person who is not dead yet when she starts going back in those, which includes people such as her parents. So I thought it was kind of interesting because there were some sort of odd moments when she's transported into the body of her mother. It's kind of weird.
Strange.
So I thought, okay, suppose that's going to happen to you. You get
Do
transported.
we have to find a dead body?
You don't have to find a
Okay.
dead body. You just get transported back into somebody else's body. So first, somebody 30 years ago.
Oh,
Who do you want to spend a day? And you're still you.
sure.
You're just in their body, and everybody is going to be reacting to you as though you're that person. Who do you
Yeah.
want to be?
Classic switch.
Yeah. Jim?
30 years ago, I actually just had my birthday a couple days ago, so I was 17 30 years ago.
So you just want to go back to your own body?
No, what I want to do is, when I was 17, I was a late bloomer. I was not very successful with the ladies back when I was 17. So I'm going back to my first year college roommate, Brent. Brent, if you're watching, when I went to go see him, I mean, he was tall, luxurious hair. He was built, and man, did he do well with the ladies. I know because I was in the room a lot of times. I wanted to be Brent at 17.
So it wasn't just not knowing the moves. It was not really having the right.
It was the hair. It was the luxurious hair.
It's the whole thing.
Whole package.
Now I realize that it's a lot just like confidence and moves and stuff. Like even me and my body back then could have done all right, but it would have been a lot easier if I looked like Brent, the most gorgeous person I've ever seen. So,
all right, interesting answer,
like that.
Patty. What do you think?
I don't know. So I feel like I need to do a little research or something. So if I went back to 30 years ago, I would be 8.
But you're still you, okay?
But I'm still me.
You're yourself today.
But like, I don't have memories really from when I was 8. Like, I don't know who was around me. But the 30 years ago, right? I'm trying to think of the time frame, and like what cool things were happening then. But like, I needed to do research. I should have done some historical research.
What about if I say, okay, anybody at any time?
Oh, that's complicated. That's like too open-ended though, right?
Jim, what do you think? Addie is too stumped here.
I'm too
Well,
stumped on this one.
she's gonna think if you could be anybody at any day for one day, you're still you, but in their world.
I don't know. I was thinking of I'm gonna be Chandrasekhar.
Oh,
Oh,
okay.
He was
that's
awesome.
Yeah.
fun.
He
What,
won the Nobel Prize in physics for thinking about the white
white
dwarfs
dwarfs?
and things like that. But he did that while he was like in a boat on the way from India to England to do his. So he was like a college student.
Okay, but which day do you want to be him? And bear in mind, you'll only look like him. You're not going to have all those brilliant ideas. So if people are asking you about to explain white dwarfs, you're going to look like an idiot.
I'm gonna look like an idiot. Fine, but I'll have it written
You're
down.
okay with that?
He wrote it down, and then I can take credit for it. It's gonna be awesome.
Yeah. I think I'm just going to be whoever's married to Kate Winslet at that particular day.
Oh, there you
3
go.
years ago was she?
Whenever. Maybe not
That's
30,
right. Now you get to go whenever. Okay, all right.
maybe not 30 years ago. Maybe when she won an Oscar, she was probably really happy that night. Maybe that day.
Yeah. I
Kate
think
Winslet's husband or boyfriend on the day she won the Oscar.
there you go. I think
I'm having much, that just shows you I have a much different standards of what's important than Jim does about, Jim's thinking white dwarfs,
oh, I mean his first
Nobel
answer was very
Prizes.
much in line with yours, Josh.
That's
His
true.
first
That's
answer
true.
was much more. Yeah, I was trying to think. I feel like so I need to look it up, but I guess I would try to go to like one of the astronauts that was probably if it was like
Well,
1992.
I'm so embarrassed.
I would
Now I,
probably try to switch bodies with like somebody who was up on the space shuttle at that time because I think one of the Hubble servicing missions was around like in the early
well,
90s or Hubble
uh,
missions then too,
now I
right?
feel like now I feel truly shallow and stupid for not thinking first if I could go to anybody anytime, go to one of the freaking astronauts on the moon.
Yeah, also that.
Duh.
Yeah.
Yeah.
Gosh, dummy. Oh man, I'm a terrible person.
You just
Anyway,
hadn't prepped for it. It's fine. It's a
good
Stumper,
answer
Josh.
though, Addie. You weren't you took your time, but then you came up with a really good answer.
Thank you.
Well,
Thank you.
today we'll talk about gravitational redshift, but first, this episode of Walkabout the Galaxy is brought to you by the Pleiades. Combining three consecutive vowels and at least 1,000 stars, this open cluster is no constellation, but it does catch the eye with its bright blue B type stars in the prime of their half-billion-year lifespans. Partnering with the Hyades to form the Golden Gate of the Ecliptic, let the Pleiades be your gateway to the prime of your life. Find your way on your walk about the galaxy with this bright asterism near the vernal equinox, the Pleiades, confidence in motion.
I've never heard of that term, the Golden Gate of the Ecliptic.
Yeah, me
Well,
neither.
this is why people listen to this show, Jim. It's not to find out who you and I want to be sleeping with 30 years ago. It's to learn things like the Golden Gate of the Ecliptic. So the Golden Gate of the Ecliptic, the Hyades and the Pleiades are two visible to the unassisted eye, sort of open clusters, dense regions of like a lot of stars in a small space. Straddling the ecliptic, which is the line across the sky where the planets are located from our vantage point here on the Earth, north and south of it by roughly equal amounts, and kind of near the vernal equinox. Yeah.
Cool. I like it.
So every now and then you'll find a planet there, sort of in between the Hyades and the Pleiades, and that's a nice naked eye or binocular view.
Ooh, Katie Sullivan was on one of the flights in
She's
1992. She's pretty
still,
awesome.
Addie's still hung up on 1992.
Yeah.
Confidence
Um.
in motion, and
Uh.
this one you have to get it. Come on,
Confidence in motion.
for the Pleiades.
Is it Subaru?
Subaru.
Yes,
Okay.
great, because the Pleiades is called Subaru in Japan, and that's
Yes.
one of their many taglines.
I
Great.
decided my next car is going to be a Subaru, so I like it.
The
Okay.
Pleiades upset me though because I think that it's like the Seven Sisters, but there are not seven naked eye visible stars.
Well, right. there are, I mean, depending on the scene conditions and how good your eyesight, there may be 7, but there's usually either fewer than 7 or more than 7. It'd be sort of unusual conditions to see 7 and exactly 7. It's really, there are 5 or 6 that are the brightest.
Yeah, I want to say 6 is the most that I've ever been able to like.
Yeah.
Concept.
And if you see a picture, you can like, here are the 6 brightest, and after that, you're kind of like, I don't know. And there's a bunch of other dim stars, right? Yeah. In any event, we have. We're going to come back to the Pleiades in our trivia in a little bit. There's a lot of space news. There were some. Speaking of stars, there were some really nice JWST focusing and alignment pictures have been published.
Yeah.
These are comparing the best previous infrared images of certain regions of the sky taken with space telescopes with what's now being taken with JWST. And boy, a lot of people who spent a lot of time on this project are really, really happy because it worked. The spacecraft worked, the rocket worked, the spacecraft worked, the telescope is working, the instruments are working, all sort of exceeding the baseline threshold that they're supposed to be at. And there are some beautiful pictures which will be posted, of course, by your friendly Walkabout team. Have you seen these images?
Yeah,
they're really impressive. I mean, to be honest, though, I don't know. It's a little bit. It's weird comparing those images to like we think of the JWST as like the successor to Hubble, but it's not really, right? Because it's in a different wavelength. It's an infrared telescope, and we haven't had any previous infrared telescopes that were anywhere near as sophisticated or large, right? I mean, the one they're immediately comparing it to is the Spitzer Space Telescope, right? Which is this awesome thing that's been up there forever, but it's radically smaller. So it's not the least bit surprising that we're getting much bigger images. But yeah, it's a really
we'd be kind of stupid if we had just built a new one that was like marginally better than the previous one. So that's kind of part of the whole point of the thing is that yes, it is much bigger and it should be much better, and then it's just gratifying. Guess what it is?
It is, yeah. No, all I was saying is like it would be cool to see Hubble versus JWST, but you can't really compare those because it's apples and oranges in some sense because they're different wavelengths regime. But even if you were, JWST is better. It's awesome.
Well, yeah, I mean, it would be interesting to see that, and it is a difficult comparison to make because JWST is, as you said, is making these observations at the images I've seen have been at like 5 or 6 microns or something like that. So the wavelength is about 10 times the wavelength of the light that we see with our eyes, and that Hubble was mostly measuring in the near ultraviolet and the visible part. So yeah, it is a different sort of comparison, but I would be still interested to see like a picture of the Pleiades in Hubble and JWST. I'm sure it will eventually.
I'm sure you will see things like that soon. Yeah.
So they're gearing up for science observations. We have other space news too, Addie.
Yeah, I like to find these. I subscribe to news alerts from spaceweather.com, and that's where I get a lot of my like solar activity updates and like aurora updates and things like that. But there was a new.
Where do you get your solar activity updates from, Jim?
From Addie, usually.
He just looks outside.
Okay. I just thought it was funny. It was like, that's where I get my solar activity and aurora updates from. I don't know where you guys get yours from.
I do have approximately 7 weather apps on my phone. So I don't have any space weather apps, though. I need to see if I can do that.
I was going to say, yes, you should do that.
But this was a couple days ago. There was another fun phenomena. So we've talked a little bit about different types of sprites, which are just different types of like interesting upper atmospheric phenomena that are sort of like aurora, and that they're sort of electrical and they ionize gas. So we see them, but they're very different than aurora. They're usually like atmospheric interactions.
They're sort of like a cross between aurora and lightning.
Yeah.
Visually, in some sense, probably physically not, but they
not physically, but
way up, very, very high in the atmosphere, though.
Very high. So typically they're seen from like satellites or from like space, like they were first discovered from space shuttle observations. And so they're seen on some ISS images and things like that too.
If you do some
Um,
more research, you can find out if you can go back 30 years into the body of somebody who saw some sprites from the space station.
yes, or the space shuttle if it's 30 years. Yeah,
I'm sorry. Yes, space
yes.
shuttle.
Yeah, I think. Well, was there a space station 30 years ago?
There was something. There wasn't Skylab. There might have been a
No.
mirror.
Yeah, there might have been a mirror. Um, but so there's different types. There's thing we've talked about Steves a few times before, and there's also elves, which apparently ELVE elv is. I think this is the first time I've seen it spelled out. This is a terrible acronym, and I'm doing air quotes there because it's not an acronym. They just picked like four of the letters in this really
Oh,
long set of words. It's short for emissions of light and very low frequency perturbations due to electromagnetic pulse sources.
and that became ELVE, ELVE. Yeah.
Yeah.
Okay.
Or elves usually, but like what? No. Um, but so this was one that was seen over Texas, and it was just like a really big 100-kilometer wide red ring of light that appeared over West Texas. And it has to do with these upper atmospheric phenomena. It was generated by a lightning stroke, a really strong
Lightning
lightning.
stroke.
That's what it.
Can you convince me it's not aliens?
I know. I was just going to ask that.
I can't. Probably yes.
Then aliens it was. All right.
Actually, that's a good space news article, but item. But yeah, it's basically like you get an electromagnetic pulse and it hits the ionosphere and it makes this cool atmospheric phenomena.
Cool.
I don't know, I thought that was fun.
You know whom we haven't, what commercial launch company we haven't talked about much recently?
No.
Virgin Galactic.
Why haven't we heard from them? Are they not launching?
That's exactly why we haven't heard from them. They're not launching, and they have announced that they are planning to resume flights in the fourth quarter of this year, 2022, with a first commercial passenger flights in the first quarter of 2023, if I have that right. So,
Yep.
not a lot of details about what's been slow. I know that they've been working on their sort of like version 3 space vehicle, which I'm sure addresses, the newer version, probably better, lighter, faster, stronger, all those good things. So that'll be something to look forward to. They do have a long list of paying customers who are waiting for their ride to the edge of space. So, and speaking of cool things in space, there was a launch by a company that we do talk about a lot frequently, which is SpaceX. And SpaceX had another Starlink launch this morning. So the space jellyfish, I missed the space jellyfish, which was a pretty interaction of light with exhaust from the SpaceX Starlink launch this morning.
Yeah,
High enough
I
in the
missed it.
sky that the sun hits it while it's still sort of dark because it hasn't really had sunrise yet.
We're at the time of
Yeah.
year where sun rises pretty darn early, so you gotta be up at the crack of dawn if you really literally if you want to see that.
Yeah, I
Or,
was up a little bit before it, but I didn't go outside to look at it.
yeah. Well, before we get to our science topic of discussing gravitational redshift, which involves one of my favorite topics that I don't understand very well, which is general relativity. Let me go ahead and let you know what our trivia is today. Our trivia is inspired by our sponsor, the Pleiades, which
Great.
is an open star cluster. A lot of people, Jim, you mentioned that you were bothered by it being called the Seven Sisters, and people sometimes look at it and go, "Oh, is that the Little Dipper?" Because
I
it
call it
has
the
the
mini.
sort of the Mini Dipper, right? Or the yeah, it's somehow the brightest stars vaguely you resemble a pan or something like that, if you wish. And some people do confuse it with a constellation, which they were careful to point out in their sponsor message. They're not a constellation. A constellation is an apparent pattern in the sky of stars that don't actually have any physical relationship to each other. They're just in the same direction of line, roughly in the same direction of line of sight from the Earth, forming some kind of shape or pattern in the sky. These stars are all in a cluster called an open star cluster, and it's close enough to the Earth 444 light years, give or take, that we can make out the individual brightest stars with the naked eye. Another name for the Pleiades is, besides Subaru, from a catalog. Does either of you know its catalog identification?
Messier something?
Yes, Messier something. It's Messier 45, M45.
I was going to guess like 50 something. I figured it'd be
Oh,
lowish.
okay.
Nice.
Nice.
It's M45. Okay, quick bonus early trivia. How many objects are in the Messier catalog? This was created by French astronomer Charles Messier in the 18th century.
Yeah, I don't know. 300.
There's a lot.
How many did you say, Jim?
300.
300?
Yeah, I was going to say like 400 or 500.
Only 110.
Oh, okay.
And
I feel like I remember higher numbers than that, but I guess I don't.
Not with an M, not with the M in
Maybe
front.
those NGC is that other catalog.
NGC
That's
is
true.
thousands, right?
Yeah.
Which is the N general catalog or something like that. The Messier catalog, Messier had 102 objects, but then it has 110 now. How, you may be asking? Because in years since, people saw things and then noticed that Messier himself had made notes about it in his notebook, but had not formally identified it. And so they sort of honorarily, retroactively dubbed these as new additions to the Messier catalog, most recently only being 50 or 60 years ago in the 20th century.
NGC stands for the New General Catalog.
New General Catalog. Yeah, you never hear about the OGC.
Yeah.
I do hear a lot of talk about the OG. I'm going to say, do you mean the OGC? The original General Catalog? I only use the New General Catalog. In any event, what's the trivia? Okay, Josh. Messier's original catalog, 110 objects. 2 questions. What type of object is the most common in the Messier catalog? When he was looking at this stuff, we didn't understand the universe really at all. We thought the Milky Way was the whole universe. And all the stuff that we saw in it, we thought was like nearby, right? And we didn't know what the difference was between a galaxy and a cluster or even a nebula sometimes. So there's all lumped together in this catalog. So which of the following type of object is most prevalent in the Messier catalog? Spiral galaxy, elliptical galaxy, Jim, for you, annular galaxy. What's your favorite kind of galaxy?
I'm going to go with spiral annular. There's no such thing as an annular galaxy.
You just made that up.
Galaxy. Globular cluster, open cluster, or nebula?
Oh, it's hard. I like that we get multiple choice, though. Those were the ones I was going to pick from. So
okay, good. And then the second question is also multiple choice. I'll just give that to you after we've done our thing, and we're going to answer the first one. So, let us talk about our galaxy in a sense, and more particularly Sagittarius A star.
Yeah, we're all geeked up about that nowadays because soon, and we're not going to talk about this episode, but the Event Horizon Telescope is about to say something about Sagittarius A star. Show us.
Do we know what's about Sagittarius A star?
We do.
Okay.
Yeah, it's about the thing at the center of our galaxy. I mean, presumably they're going to show us pretty pictures of it, and there's going to be some interesting factoids about it. But we don't know. There's for us recording this on May the 6th. It's another week or so until they have their press conference.
And just as a reminder, Sagittarius A star, which you referred to as the thing at the center of our galaxy, we know a little bit more about it than the thing at the center of our galaxy.
Yeah. So that's of course a supermassive black hole that lives at the center of our galaxy. It's has the mass of about 4 million times the mass of our sun, and is a beast. Hard to see beast because it's living at the center of our galaxy, and there's so much crap in the way between us and them. But
it's sort of like trying to see the skyscraper. It's trying to see buildings downtown when you're on street level on the outskirts of that town.
Yeah, or trying to see your own spleen or something. Yeah, it's hard. Have you ever tried to see your own spleen?
I haven't.
That's very different and odd comparison, but okay.
But in any event, so we'll save the Event Horizon Telescope news, of course, for once they talk about it, and you guys will, I guess, at MegaCon there, or DragonCon, or whatever that con is, you guys are going to... I'm very jealous, by the way, of Dr. Hannah Sargent for two reasons. One, she is currently, as you said, she's not on our show today because she's in Luxembourg, isn't that right?
Yes.
Yeah.
That's freaking amazing. I would love to see it. That's a cool little tiny country in the middle of Europe. Awesome. And she gets to hang out with you guys at that conference and talk about the Event Horizon Telescope. So that's
definitely, to all our listeners, we welcome you to come hang out with us at MegaCon and talk about the Event Horizon Telescope or Star Trek or something called, what's that? There's some, I don't know, there's some anime, Hero Academy thing that I discovered at the last MegaCon. Anyway, we're sorry you're not going to be there with us.
I know, Jim. It is a bummer. But
I'll cosplay as Jim.
Oh, nice. So he'll be there somehow.
Yes.
So even though I'm going to miss that and not going to be able to talk about the Event Horizon Telescope stuff, we can talk a little bit about Sagittarius A*. And this isn't a new result, but an interesting old one that I don't think we've mentioned on the thing before. That is yet another way to test Einstein's theory of general relativity, which we know and love and have tried to test many different ways. And one of them is by looking at stuff that lives near Sagittarius A*. So Sagittarius A* being a black hole, the space and time around it are ludicrously warped. And so if you can find things that are near it, weird things should happen to them. And one of the cool things that's near it is this star, which is this weird name. It's just
stars mostly have weird names.
Stars do have weird names, but usually when I think of a star, it has like some long name. It's either a bright star that has a name like the constellation and a Greek letter,
right?
Or it's a really bright star and has its own name, like Betelgeuse or something,
right?
Or it has a really long list of alphanumeric stuff. This one's just S2. This is the name of this star, and it is a star that orbits Sagittarius A* quite closely. And in a very elliptical fashion, in a very eccentric way, so that sometimes it's very, very close to the black hole and sometimes it's a little bit further away. And there's a couple things we can do with that. One is look at its orbit. Its orbit is a little bit different than what Newton would have predicted its orbit looks like. And there's this cool, fun thing, the thing that we promised to talk about, which is gravitational redshift. So that is, if you have a source of light coming to you from near a very massive object, that light struggles to get out, right? As the light is heading towards you, it loses some of its energy. Just like if you throw a baseball up away from the Earth, it loses energy as it goes up. Well, light can't lose its speed like the baseball does, but it can lose energy. And light losing energy means it's longer wavelength or lower frequency. So that means light gets redder as it's moving away from a big, massive object. And so,
and now, just to clarify, this is different than another phenomenon called the general relativistic phenomena that we have talked about before, which is gravitational lensing.
Right. So this is
spoken of recently, which also involves. We've talked about light from stars passing near black holes and getting deflected.
Yeah,
that light is not having its energy changed in any way or any significant way by that passage by the black hole. Is that right?
That's right. It's just changing the direction it travels, which means you see it apparently coming from a different position. And so we've measured that, with stars that are really close to the sun and so forth. That was actually the first ever successful test of the general theory of relativity, when we saw stars move their position when they're near the sun. Yeah.
Whose line of sight passes close to the sun. They're not actually close to the sun.
Right. Of course, yeah. I mean, the path of the beam of light from the star grazes the sun and thus bends and appears to be from a different spot. Of course, that's hard to do because the sun is friggin' bright. So they had to wait
that's done during a solar eclipse.
Right.
This phenomena is a very different phenomena, this gravitational redshift.
Right. And it's one that is a subtle thing, and you have to be. It's one that you wouldn't easily measure, for example, for light that's coming near the sun, because the sun's gravitational pull just isn't strong enough to significantly shift the wavelength of the light. But Sagittarius A* is a beast, right? 4 million times the mass of the sun. So that thing can significantly shift the wavelength of light. And as we watch that star S2 go, and the thing is, that star is so close to Sagittarius A star that it has a period of like 16 years, I want to say. So it goes around once every 16. But that means we can sit there and watch it, right? Over the course of the last decades, we've seen a couple full orbits, which means we can observe it when it's further away and when it's a little bit closer and compare like the color of the star. And it's actually notably redder when it's close to the star. And I think that's a really cool thing. And you'd said you'd even seen the images of that where, you can actually see it look redder. And that's probably a little bit artificial, but it's observational. Notably,
we have the data that show it, and then there's a graphical representation of that. But so there's a couple of key things that make this possible, right? One is you have to have a star that's like literally physically close to the black hole, not in the same direction as the black hole, but
right
close to it, so that it's like in that. We have this frequently this simplified notion of a black hole as a deformed sheet of rubber or something that where the mass is distorting it way down. And this light source is down in that hole part way.
Yeah.
So as you were saying, it takes energy for the light to get out. For that energy comes from the wavelength of the light. It becomes longer, redshifted. And that's the other thing you have to have is then you have to have the star sometimes not be so deep in the hole so that you can do a color comparison. Because if you just have a star close to it, you just go, that's a red star.
right.
You don't know that it's red because it's struggling to get out of that gravitational hole. It's only then by comparing, it's like, oh, here it is 8 years later when it's farther away, and it's exactly as much less red or bluer as predicted by Einstein.
Yeah, that star S2 is just like the perfect experimental playground for general relativity because it is so close to the black hole and has that eccentric orbit, so it gets closer and further. So it's a really fortuitous thing, and the fact that we can see it and watch it do the whole thing is freaking awesome.
And we also clarify that this could be confused with the Doppler shift, and it is not that.
Right.
So stars orbiting other stars can appear redder or bluer because they're moving away from us or moving towards us, which changes their color. But this doesn't require the motion of the star at all. It's just sitting there.
Totally independent. Yeah, I mean, and obviously that does happen, but we understand the motion of that star well enough. You can just kind of subtract that out and see that it's redder when it's closer. That's in just precisely the way that the Einstein's equations predict. So
that guy.
If you're the score sheet of like his predictions, everything else, he's got so many tallies, and the other side of the board is just empty.
He's doing pretty well.
Killing it.
He's doing pretty well.
Yeah.
One of the crazy things I noticed when we were reading that article, though, is like how fast that star has to go when it's closest to the black hole. It goes something like 2.5% the speed of light.
Right.
So like. You are gonna get some red shifting,
really significant
there.
Right,
some speed shifting, speed red shifting there. But it's crazy. That's moving.
It is moving. Yeah, I mean, it's moving fast enough that you have to worry about special relativistic effects in addition to general relativistic. This is a complicated thing.
That's so fun.
It's going around 4 million solar masses, and if it weren't going that fast, it'd fall down. Super cool. And as you said, we're expecting some sort of announcement about the Event Horizon Telescope, which had initially their plan was we will take a picture of 2 supermassive black holes, event horizons.
Right.
One was to bring us back to our trivia, the supermassive black hole at the center of M87, I believe,
M87,
which is truly a beast, a much more massive black hole.
Yeah, that thing is like 1,000 times more massive than Sagittarius A star, but it's 1,000 times further away, which means 1,000 times smaller, which means about the same size in our sky.
Right. And they, for some reasons, which I don't fully understand, they were able to do the M87 supermassive black hole. I kind of feel like Sagittarius A star shouldn't be called supermassive if it's 1,000 times less massive.
Well, I think M87 star, that one that's like one of the largest known. I mean, that's truly an absolute beast.
Maybe it's
extra
hypermassive.
supermassive.
It's
hypermassive.
Yeah. It should have a cooler name than that. Yeah.
Okay.
Yeah.
Right. And so we have been expecting or hoping to see an image of the event horizon of the Sagittarius A-star black hole at the center of our own galaxy. The press release teaser indicates that there's something unexpected, that it's not just we have the image, that there's a discovery of some sort there. Since we know there's a black hole there, seeing it is not really a discovery. So we're all very interested to see what that is. That'll be coming up on a future episode. But now, speaking of M87 and Messier objects, let's revisit our trivia questions. So the first question is, what is the most prevalent type of object in the Messier catalog? And these are, if you have your own sort of backyard telescope, these are a good set of objects to train your telescope on, because
the idea with this is like he was trying to catalog all of the things that you could see with the telescopes of the day that weren't comets, so that you could tell what was a comet, right? All the things that obviously aren't stars, not point objects, but are also comets. So fuzzy things in the sky.
Right. So your choices are spiral galaxy, elliptical galaxy, globular cluster, open cluster, or nebula. I will not accept annular galaxy as a name.
I gotta say, Josh, this is a good trivia question. I like it because I all of those seem plausible to me. This is a difficult thing to answer.
I was going to go with cluster, but I hadn't decided before you gave us our multiple choice options, but I hadn't decided which type of cluster. But I'm going to go with open cluster.
Okay.
I'm going to go with globular cluster, just for fun.
Okay. Well, I'll tell you that Jim's hunch that it was a tough question is right, because it's the top three are very close to each other. There are 27 spiral galaxies, 26 open clusters, and 29 globular clusters.
Oh, all right.
So Jim
nice
gets that.
Jim.
Now, we've mentioned that the Pleiades is M45. M87 is an elliptical galaxy with a hypermassive black hole.
I really like M11.
Okay, well, you might be able to get this one, Patty, or maybe both will. Which object is M1? And I will give you multiple choice for this one as well. Okay, M1. Which object has the honor of being first in the Messier catalog? Is it the Great Galaxy in Andromeda? Is it the Orion Nebula? Is it a globular cluster known as the Great Sagittarius Cluster? Is it the Crab Nebula? Or is it Albireo, which is a double star system?
My intuition, I was mouthing Andromeda before you gave us the options.
Yeah.
So I'm going to go with that.
Andromeda. Okay.
Yeah, I wish I knew like how he ordered. Like, was it like the most obvious ones first, or did he start at some particular part of the sky and then move on? I don't know. So I don't know. I'll go with the Orion Nebula.
I stumped you both. It is the Crab Nebula. I do not know what his system was, if he was going systematically in some way or another by location in the sky or whatever. The Great Galaxy in Andromeda actually is the only one that I remember, and it's M31.
Okay.
But in Albireo, which is another fun target for backyard astronomers, is a double star system, which by itself doesn't sound so interesting, except that the stars are quite clearly different color.
Yeah, really.
One is quite clearly blue, and the other is quite clearly red.
Yeah, that one's super fun.
Very obvious. It's a nice, fun thing to look at, but it is not actually in the Messier catalog at all.
I didn't think it was. Okay, good.
Yeah.
Well, I thought you might be trying to trick us by because it seemed like it shouldn't be in the catalog, but it's inclusion in
that was my psycho. That was my psycho attack on you, Jim. Was to put something that wasn't in there.
Yeah.
You would think wasn't in there, that would make you think that was my attempt to try to trick you, and that was really it.
The crab is an interesting one because that's the one, like a lot of people when they're doing like first images with new detectors and new telescopes and stuff like that, or like an X-ray, I think a lot of times like sounding rocket stuff, they always look at the Crab Nebula. So that's interesting that it's also M1.
Yeah, that's one of the ones that I would think that's like a subcategory of nebula. This is like a supernova remnant, is what the Crab Nebula is. I would think that's one of the rarer things in the Messier catalog, because there's not a ton of those that are visible to telescopes in his day.
You are correct, sir. There are only 7 nebula of any type in the Messier catalog. And so, as you mentioned, the Crab Nebula is a supernova remnant. The Orion Nebula, which is in the Messier catalog, is sort of a star-forming region nebula. There's a planetary nebula, which doesn't have anything to do with planets. It's called that way because of its appearance in small telescopes, which is the nebula produced by different kind of stellar death than a supernova. So yeah, only a handful of those in there. While it may have felt like reliving someone else's life for a day, it was just another episode of Walkabout the Galaxy. Give us 5 stars and we'll give you the universe. Be sure to follow us on Facebook and Instagram to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel. Our videos now feature chapter markers so you can skip to the good stuff, whatever that may mean to you. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter
at walk_the_galaxy.
And ask us questions anywhere using hashtag AskWTG. Our theme music was composed by Richard Jerusik. Production assistance is provided by Logan Basinger. Thanks to our listeners in Perth, Australia, and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Jim Cooney.
We're the Astroquarks signing off until the next episode of Walkabout the Galaxy.
M83.